It's about trigonometry ratio. You're on page 1, right?
Page 7.
Page 7, exactly. So, you remember trigonometry ratios, what we normally call Sohcahtoa.
Yeah.
Sohcahtoa. You know. So for sine, K for cosine, T for tangent, and sine is opposite of a hypotenuse. Cosine is adjacent of a hypotenuse, tangent is opposite of adjacent. Right?
Yeah.
Okay. We apply trigonometry ratio usually with right angled triangles.
Okay.
You know what are right angled triangles? Triangles that have angle 90 degree. You know, a right angle is actually angle 90 degrees. So if the triangle has angle 90 degrees, it's a right angle triangle. And this is the sign you normally see to whenever you have a right angle triangle. This sign means 90 degrees because it forms a perpendicular line like this. For a right angle triangle, you need to identify certain sides, the hypotenuse, the opposite, and the adjacent. Now it depends on the angle that you are considering. If this is the angle we are considering, the side that is facing the angle is called what? No, the side that is facing the angle we are considering. Opposite. The other side is adjacent. What I mean by the other side, we need to first of all identify the hypotenuse first of all. Now, how do you identify the hypotenuse? Some people say the longest side, but when you cannot measure, how will you know it's the hypotenuse?
Yeah, just to measure.
Well, you know the hypotenuse by checking the side that is facing angle 90 degrees. You know, this is angle 90 degrees. This side that is facing it is the hypotenuse. So it's always the longest side anyways. It's always the longest side. So angle 90 degrees, the longest side, which is the side that is facing it, is the hypotenuse. Now when you are given an angle, the side that is facing that angle you are given is the opposite. The other side is adjacent. So let's use this to illustrate this first of all before we continue. Look at this shape. I'm going to draw it here. You see, that's why I said the longest side thing may be, well, it will always appear to be long, or always appear to be the longest if it is drawn properly. That's a challenge now because you may not know which side is actually the longest. So let me give you this. Look at PQR.
This place down.
Okay, let me show you first of all. This is how we name sides. This is how we name sides.
I know how to name sides.
Oh, that's cool. So the side that is facing the angle is given as a small letter. So angle A, then the side facing it is small letter A. Angle B, the side facing is small letter B. Angle C, the side facing is small letter C. In fact, we use capital letters for sides.
Yeah.
The small no, capital letters for angles.
Yes.
Small letters for sides. Except when you want to mention a side by 2 letters. Like I can call here AC. AC is actually small letter B, is it not? AB is what?
Small letter
C. Then BC, small letter A. It is A because it is facing capital letter A, which is the angle.
Sorry. Do we need cosine rule IG?
Yes, you do. You do. Alright, we'll get to all of that. It's in another lesson I will show you. I'll take you on that too. Now look at this. If you know these sides, can we mention, we know the angles. Can we mention the sides first of all?
Small letter P.
Where is small letter Q? P, use two letters to show me where small letter Q will be. Is it P to Q, that is small letter Q, or Q to R, like small letter Q, or P to R?
P to R.
So P to R is small letter Q. Alright, so that's small letter R. You're right.
Small letter Q.
Small letter Q is where? Oh, small letter Q, sorry.
Yeah, okay.
P to R is small letter Q.
R to Q is small letter P.
R to Q is small letter P. Okay.
Yeah, P to Q is small letter R.
P to Q is small letter R. Alright, that's correct because this R is facing it, and so on. This P, this small p is facing it. Okay, so now since we know that if this place is 60 degrees, where is the hypotenuse?
RQ. What letter Q?
RQ is, where's the hypotenuse again?
Yeah.
You see the point I'm making? Because I didn't draw this to scale.
It's facing the right angle.
Where is the right angle?
There's one
See the
60.
right angle. See, no, the 60 is not right angle. Right angle is 90 degrees.
Okay.
So where is the hypotenuse?
Yeah.
Where? It has a letter. So R is the hypotenuse. Where's the R is the hypotenuse because it's facing the angle 90 degrees. Just like this one too. The hypotenuse is facing angle 90 degrees. Where is the opposite?
Q. Sorry, P.
Small letter P, because it is facing the angle given, which is 60 degrees. The angle we are considering. If it was a different angle that was given, it would have been elsewhere. So where is the adjacent?
Q.
The other side is the adjacent. The side that is with the given angle. Obviously, if this angle was given here, 30 degrees, where's the hypotenuse now? Or where the hypotenuse will still remain the same, will still be R, because it is always facing angle 90 degrees. Where's the opposite now?
This place, Q.
Where?
This place.
It has a name now. It has a
Q.
Q. You mean Q? Q will now be the new opposite, because that's the one facing the angle. And the adjacent will be where now? P. P will be an adjacent. So you need to take note of that. It depends on where the angle 90 degree is. Alright, so that's that. Obviously, A, B, C, capital letter A, C is B, and so on. Okay, now naming angles too. They say another way we also name angles. If I want to mention these 60 degrees, you know, you use 3 letters such that the angle you are, where the letter where the angle is formed will be at the center. So we can call this ACB, so that the C is at the center, or BCA. All of them are about this angle. Did you get what I said? How will you name this angle? Let me indicate it with a green marker. How will you name this angle?
All I name is
Yes.
C.
Pardon? Angle, I mean. I said you use 3 letters to name an angle. I think I might have to repeat the other one I did. I should repeat it so that you get it. When I was naming these 60 degrees, right, I called it ACB. Just name 3 sides so that the letter for that angle is at the center. ACB.
So it's not necessary.
It is very, very necessary. See, very, very necessary. Because you are giving questions and then they ask you calculate angle ABC, angle ACB. You need to know where that angle is. Actually, very necessary. That's actually why I'm explaining it. We've talked about how to name sides because you may be asked to find the length of a side. Now, how to name angles? How do we name angles? So if you are naming C, use 3 letters, but the C should be at the center. Just mention all the 3 letters where the triangle is. The C should be at the center. So we can say ACB, that is for this C, or BCA. You get the same thing. How do you name this angle 90 degrees? See the one I named for 60 degrees. I said you could have also said BCA. It's the same thing as saying BCA. Tell me how you can name this 90 degrees here.
BAC.
Yeah, that's a BAC. Or how else can you name it? CAB. The same thing. Do you know what this angle will be? What will be the value of this angle? I mean value, first of all.
ABC.
No, where the name is ABC or CBA.
It's not 90 degrees.
No, what? Are you sure?
Yeah.
You know the sum of angles in a triangle is what?
180.
So what should be the value of this one?
Yeah,
But you have you know what to do, because this is 90,
60,
60, so this has to be 30. Yeah, that one should be 30 degrees. ABC should be 30 degrees, which is this. All right, so let's move on to the ratios. Don't forget that you only apply trigonometry ratio, the sine rule, the sine ratio, cosine ratio, and tangent ratio with right angle triangles. You can also use Pythagoras Theorem. So the full thing is trigonometry ratio and the Pythagoras Theorem. So let's look at this, an example. Assuming you're asked to find B, you see why it's good to understand how to name angles. For instance, this question, we are required to find the length of B. See, I solved this earlier, so I should. Okay, yes. To find the length of B, this length of B, how do we find it? How do we find this length? How do we find it?
So that's adjacent.
Yes, this is adjacent, correct?
So we need to use so opposite of hypotenuse.
Let's see. It depends on what you have given.
But is small letter A given?
Small letter A is not given. Good. Small letter A is not given. So since small letter A is not given, that means we need to think of something else.
We can use our angle first.
Yes, we'll use our angle. But small letter A is not given. By the way, small letter A is hypotenuse, isn't it?
Yeah.
But we don't have it. And we're looking for B, which is adjacent. If we had hypotenuse, adjacent with hypotenuse, like you said, we would have used cosine. Scar. Adjacent with hypotenuse.
We can use so.
We can use so. Yes, opposite is given, which is 5.
But
But H, hypotenuse is not given, so we can't use so. And if we even use so, why do we even need to use so? What we're looking for is B. It's not in so. There's no B. You can't find a B in so. Look at it. Opposite hypotenuse for so. The B is not even mentioned.
Can I use TOA?
I think we should use TOA.
I failed this question in exam.
You see,
So-
you will get it now. I'm happy that you're learning it. You see, it's actually very easy. We are going to use TOA. So TOA is what? What over what?
Opposite over adjacent.
Opposite over adjacent. Why are we using TOA, by the way?
Because we're looking for adjacent.
We're looking for adjacent and opposite
Hypotenuse
is given.
not given.
Yes, we're looking for adjacent, which is the B, because we are asked to find B. Find B. Okay, you want to try it? Find B. That's cool. Let's try it. See, we're going to work very fast now. You see how all of this will be resolved. Find small letter B, not angle. This is side. small letter b, which obviously is adjacent, and opposite is given 5, so it is about opposite and adjacent, so it's toa. So what are you trying to do?
Trying to do. I'm not sure.
Just let me know.
Tan x.
Tan the angle is given now. Why are you saying tan x? The angle itself is given.
Tan
60. Yes.
equals to 5.
So tan 60.
I need my calculator.
Okay. Tan 60 degrees is equal to, when you're solving this, make sure your calculator is set in degrees. So, because if it is in radian, it will be giving you a different answer. Is it set in degrees? So tan 60 degrees is what?
1.782.
No, what did you do first of all? Tan 60 degrees, you need to express it. And tan 60 degrees is, oh, that's cool, beautiful. Because tan is opposite over adjacent. Tan is opposite over adjacent. So you should say 5 over b. Is that what you wrote? Or 5 over x? Alright, so 5 over b. And you cross multiply, right? Because it's like saying tan over 1, tan 60 over 1. Anytime you see any stuff without anything, it's like over 1. So you cross multiply. So 5 is equal to b times 60. Okay, you've already found tan 60. So can we just say b times sine 60, b tan 60 is equal to 5. So how do we get b? You divide both sides by tan 60, is it not? Okay, so let me have what you have in your calculator.
Yeah.
Give me your answer. Divide both sides by tan 60.
My answer is 2.88.
So b is equal to 5 over tan 60. You got what? 2. Yes, 2.88 centimeters. It's always good to leave your answer, your final answer, to 3 significant figures, especially if it is what is required. 2.88 centimeters. Alright, that's fine. What about if you're asked to find A? We're looking for A this time around. How do we find A?
Use sine.
Sine, because why do you want to use sine? Opposite and hypotenuse. The opposite is already given. The hypotenuse is now what you're looking for, which is A. So you can use sine. But it looks like we can even use something else. We can use cos, because we have found the adjacent now. So we can use the adjacent with the hypotenuse. Okay, so let's go ahead and do that. Let's use sine. Yes, let's use cos. Cos is adjacent. Sorry, sine. Sine is adjacent, opposite of hypotenuse. So 5 sine 60 will be 5 over A. Am I right? Is that what you wrote? Okay.
0.866.
Okay, sorry, let me work it out here. So sine 60 is equal to 5 over A. Alright, sine 60 opposite over hypotenuse, sine 5 over A. So how do we get A? Cross multiply again. This time it's okay. Sorry, let me just write it down. So A sine 60 is equal to B is equal to 5 when we cross multiply. So A is equal to 5 over that. I don't have enough space here. I'm using 200. Okay, so A is equal to 5 divided by sine 60. And you got, give me the answer again, 5.77. 5.77. 5.77 centimeters to 3 significant figures. I hope you rounded up properly. See, there's another way you could have gotten A. You could have used a different method to get A. You remember Pythagoras Theorem?
Yeah, I think so. Isn't it C squared is equals A squared plus B squared?
Exactly. See, once you have two sides, you can get the third side.
No, I like my method.
Well, sometimes the angle may not be given. If the angle wasn't given,
Yes.
you will be restricted to use Pythagoras
Yes.
Theorem.
Is that not that's a rule?
Pardon?
That's a rule. Like it's one of the rules.
No, it's not necessarily a rule. You can use any method.
Is it that cosine rule or sine rule?
Or the Pythagoras Theorem. But here, in this case, you can use anything. But what I'm saying is, if this 60 degree wasn't given, and we had B given, and C was given, we could easily find A.
Yes,
You know, which one would have been, you know, what you do in Pythagoras Theorem is, the two sides, square them, add them together will be equal to the hypotenuse squared. In fact, it would be, let me even write that, Pythagoras Theorem here would have been,
So you know I'm not eating today, I'm hungry.
sorry, Pythagoras Theorem would have been, state what it would be.
C squared.
In this case, be careful. State what Pythagoras Theorem will be in this case. Remember, it is the longest side squared.
Are you sure?
Of course, that's what I'm telling you. It doesn't matter what the letter is. First of all, you start with the longest. That's why I'm taking my time to explain this. The longest side squared.
Yes.
Then the other ones, put them together.
Oh, that's what I saw in Google.
No, it doesn't. I know, because in the way they gave it to you, the C happened to be the longest side.
Okay.
So it is first of all the longest side squared. In this case, it is, which one is the longest side?
A.
That's the hypotenuse squared. If you like, I can just say hypotenuse squared is equal to opposite squared plus adjacent squared. That's the rule. Do you understand?
Mm-hmm.
So whichever is A or B or C, you can now know. The hypotenuse squared, in this case it will be A squared, is equal to opposite squared plus adjacent squared, or you can say adjacent squared plus opposite squared. It doesn't matter. Just the other two, opposite and adjacent, square them and add them together, must be equal to the hypotenuse separate squared. Alright, so I said we could have applied it because we found what B is. We found B to be 2.88 and C is 5. So we could have just said, since B is now 2.88, C is already given us 5, we would have said A squared is equal to 2.88 squared plus 5 squared. See, I'm deliberately doing this because you might encounter a question like that. So alternatively, this time we can have found A. This time we would have found A. We would have done A squared using Pythagoras Theorem, by the way. Using Pythagoras Theorem, what square will be equal to what square? Show me.
A squared equals to
B squared plus C squared. I didn't say that is the way it must be. It depends on which side is A and which side is B, or which side is C. The rule is hypotenuse squared equal to opposite squared plus adjacent squared.
Yes, sir.
Alright, that's cool. So A squared is equal to B squared plus C squared, or C squared plus B squared. It doesn't matter, based on that rule. So A is what we're looking for. A squared is equal to B squared. We got the 2.88. 2.88, that's still here, right? That's still B. 2.88 squared plus C squared, we just got it as 5.77. So 5.77 squared plus 5.77 squared, 5.77 squared. So what do we do now? A squared is equal to find the square of this and the square of that.
8.2944.
8 point, put it to 4 significant figures. 8.294 plus 5.77 squared. Just a moment, let me copy it. Let me see it again. 33.23. 33.23. You know you're going to add them together, right? So a square will be equal to what? 29. Sorry, 33.29. Yeah, right. We would have made a mistake from there. So it will be an approximation. Add them together. A squared is what?
Why is it 4 here? It's 3.
This is 4 significant figures.
Okay,
This is 4 significant. By the way, you asked a good question. The final answer should be to 3 significant figures. But since this is not the final answer, leave it to 1 more significant figure. Please, that what I just said is important, okay? So what did you get for a squared? That's 8.294 plus 33.29.
41.58.
41.58. So how do we get a?
Square it.
Square. You mean square root?
Yeah.
So a is square root of all that. Square root of all this.
6.44.
Are you sure? Let me look at it properly. Sorry. No, it's far from the value. Are you sure that we didn't make a mistake somewhere? Let me be sure. Though some approximations can affect the work, but it's too far from what we got when we did it the other way. I hope the first method wasn't a mistake. Let me be sure. 5.77 sin 6 is equal to 5 over 8. Let me. Okay, you said it's 6.1. Find the square root again. 6 point what?
448.
448. So that should be 5, 4, 6, 4, 5. The values are too separated. So I'm suspecting that you probably made a mistake in the calculation of this one. So let me verify.
Sure.
Okay. This kind of thing can happen because of approximations we made here. Certain approximations can affect the work, but this is the principle. Okay, please. I need you to run through this. Look at this one. Let's do this one. Zoom in a bit. I need to see it properly. Let's see. How do we get what x, or I don't know which one you want us to look for first of all. Letter D and angle x. Side D, which is EF, actually EF.
I'll do side D first.
Okay, let's do side D first. If we're doing side D first, I think we need used to Pythagoras Theorem. So let's do that. What squared equal to what squared plus what squared?
F squared. Must we use A or?
No, you don't have to even use letters. Just use them as they are.
Oh, 5 squared.
Good. 5 squared because the hypotenuse is 5. Good. I like that. So you can say 5 squared is equal to 4 squared plus the D squared we don't know. Okay. So what is D squared?
25.
So I thought you would just move 4 to the other side. Okay, let me write 25 is equal to 16 plus D squared. You take 16 to the other side. It's better you take 16 to the other side so that D will be left here. So you have 25 minus 16 is equal to D squared.
That's
9. 9 is equal to D squared. So what's D?
That's 3.
Square root of 9. So D is 9. D is equal to 3 rather. D is equal to 3. Alright, so we found D. Can we find X?
I'm going to do sine.
Incidentally, any one can be used because all the sides have been found. We can use any trigonometry ratio. This, okay, so we're using sine, right?
Yeah.
Let's go. Sine X. We can use cos. The reason is all the sides we've found now. We've even found D to be 3. So sine X. Are we ready?
Yeah.
Sine X is what over what? 4 over. What's sine? Opposite over hypotenuse, which will be 4 over 5.
So when you look for angles, you can use sides.
Let me understand your question.
When you're looking for angles,
It's the same trigonometry ratios. Now, of course, you now express whatever over whatever it is. If you are saying sine X, it is opposite over hypotenuse, which is 4
I'm
over
going
5.
to be inverse
If you say exactly,
of
but
0.8.
if you are using cos X, it would have been whatever D is, which is 3, that's adjacent over 5, adjacent over hypotenuse. Usually we could have used tan X. Tan would have been 4, opposite over adjacent, which is 3. Okay,
So we're using sine.
We're
That's
using sine.
0.8.
The sine X is 0.8. So what is X? How do you find X? Sine inverse. No. Sine inverse of X. Sine inverse of that value you got. So X itself will be equal to sine inverse of 0.8. This is how we write it. Sine
53.1.
Sine inverse of 0.8. If you check your calculator, you see. Okay, you've seen it in the calculator. On the calculator. Alright, so sine inverse of 0.8, that gives us 53.1. In fact, angles should be rounded to 1 decimal place. 53.1 degrees. I hope this your calculator is set in degrees.
I don't know what you mean by that.
If it is set in radian, all these values will be wrong. You should always ensure, let me be sure it is set in degrees. Sine 30 degrees equals, okay, sine 60 degrees, sine 60 degrees equals, alright, it is in degrees. Okay, let's look at this second one and then we move on to applications.
So, I'm looking for small letter R.
We're looking for y first of all.
Tan.
We're looking for y.
Oh, why do I write tan?
You see y? Yeah, now that's the angle. Tan y. We're looking for y, or we can even look for r. Anyone you want us to do. I actually did r first. R, you know, to get r is the hypotenuse, isn't it? Because that's the one facing angle 90. So r squared is equal to 3 squared plus 4 squared, isn't it?
Yeah.
And that will not be difficult because r squared will just be 9 plus 16. So r squared is 25. So r is equal to square root of 25. This gives us 5. So let's get the angle now. Y. What do we do?
Adjacent over hypotenuse 4 over
3.
3.
4 over 3. But why did I use tan?
And so this facing.
Because they are the ones that are... No, they are, Toa is OR, not AO. It is opposite over adjacent that gives that tan.
Yeah.
But you gave me adjacent over hypotenuse. Tan is Toa, opposite over adjacent. So that's why we're using it, because we are giving opposite and adjacent. So tan y is what over what? Opposite over adjacent, which is what over what?
3 over 4.
3 over 4.
That's 0.75.
3 over 4. So y is 0.75. So how do we find y? Y will be what?
It's 36.86.
You did tan inverse of that, isn't it? So y will be equal to tan inverse of 0.75. 0.75. So y is 56 point what?
36.86.
36.9. One decimal place. You got 86, but it's good to round off angles. Most examiners will require you to approximate angles to one decimal place. Okay, so this is the general rule. All other questions we center around is, for instance, this one I gave you earlier to practice. We see it's just around this. Look at this question. Scroll down a bit, where you are required to find out these values. For instance, if we're looking for m, what are we going to do? What do you think we should do to find m? First of all, let's just run through. We're not going to solve it. If we want to find m, what do we use?
This is adjacent.
Are you sure? M is what?
Hypotenuse.
Remember, you get hypotenuse by looking at the angle 90 degrees.
That's is it not opposite?
So M is what?
Opposite.
Opposite. Because where is the hypotenuse, by the way?
This one.
9 is hypotenuse.
Yeah.
So 9 is hypotenuse. M is opposite. So to find M, we should use what?
Sine.
Sine. And so on. That's the way we do all of this. If you see this thing, it means these two sides are equal, right?
Yeah.
They are equal in value. The two sides. So that's basically it. How about how do we find f?
This is hypotenuse here. 36 is hypotenuse.
Yes.
And 24 is opposite.
Depending on this angle, 24 is opposite, okay? So how do we find f?
You can use cos.
The angle is not given, no? Until we find the angle, we cannot use cos. We're looking for.
You can use Pythagoras Theorem.
We can only use Pythagoras Theorem to find f.
Yeah.
Because we would have done 24 squared is equal to
36
squared
No,
plus
it's
f squared.
Hypotenuse
Oh
is
yeah,
36.
that's correct. You see why it's good for all of us to do this. Hypotenuse is 36. So we would have done 36 squared is equal to f squared plus 24 squared. Then we get it. How about if we're looking for y? We can use any of the trigonometry ratios, like opposite over hypotenuse, and use sine. That's just further practice question. Let's look at it. We just run through some of the things we need to do. For instance, you're asked to calculate h, the first one. How do we find h? This is h, by the way. This hypotenuse is 628.
Yeah. We're going to use I'm going to use cos.
Are you sure?
Yes.
H is what?
Adjacent.
Are you sure? This is the angle given. So what is this place? This is opposite.
Okay.
H is opposite.
Okay.
This is actually opposite, and this is adjacent. It's about opposite and
This is
oh sorry, this
hypotenuse.
is hypotenuse. This is hypotenuse. So it's about opposite and hypotenuse.
Yeah, that's
Sine. So we use sine for that.
Sine 15.
Okay, let's look at this one.
Okay.
How do we get this?
We still use sine.
Opposite and hypotenuse. We still use sine. Let's see. I just want us to walk through them like that.
Okay.
Let me zoom out a bit. We have to find. Well, what the question is somewhere here. Okay, this is the question.
Okay. Angle of elevation at the point P from A, so we calculate the heights.
So
We're
8.3.
looking for
The height of what? Calculate the height of P
from
above the ground.
Yeah,
The height of P from the ground. This is the ground G.
yeah.
That's from here
So,
to here.
yeah.
By the way, when they say angle of elevation, it's basically the angle that you will need to raise your eye to see something up, which is already given. Now, if it's angle of depression, the angle you will look down to see, or measure from the horizontal. So there's nothing serious about that. If you were to look down, to see this, sorry.
I think my friend that asked me.
If you were to, why is this not, okay. If this is horizontal and you were to look down to see an object here, the angle of depression will be this angle.
Yeah.
That's angle of depression.
Mm-hmm.
If you were to look up to see something, now if an object is here, and okay, let's even use this one given. So this is A and we're seeing something at P. So this is angle of elevation. If we had M here to see K here, this will be angle of depression. All right, let's go. So we have to find P to G. P to G. It's not a big deal. All we need is just find here.
Yeah, that's what
We find here. We already know the distance from G to B now, is it not?
we're looking for. Is it opposite or looking for?
We're looking for opposite in this case.
Mm-hmm.
We can call it X. Can call here X. So opposite over what? What is this place?
Adjacent.
Adjacent.
That's tan.
Tan to get X.
Tan
Now when we
8.3.
exactly when we get it, to find P to G, we just add that to 170.
Yeah.
So I'm not going to do that. I will just tell you that PG will be equal to what we found when for X plus 170. Is it not?
Yeah. Is it PG or PQ?
PG. I said something and I read something else. PG is just X plus that 170. You know, from here to here is this 170 plus the X. And you can find X using tan. Alright, next one. Tan 78.3 is equal to X over that.
Yeah. What do you number 4?
Number 4. Calculate A. Where is A?
Yeah.
Yeah. So how do we find A?
I'm not sure. They're not connected.
Yes, in fact, there are actually two different angles. I like that observation. There are two different angles. You can find them separately. You can find something from this one angle and then use it to find the other one.
You
Do
can
you
find
know we
the-
can find here?
Yes, you can find the address.
Is it adjacent? Adjacent to ADB. No, it's not adjacent in ADB. Why
This
would
line, is it not this line?
That's Y is adjacent for DBC. Yes, I know. But for ADB, it is actually what? Opposite. So we can find Y first of all. So let me just give you the clue. How do we find Y?
This is opposite. Sine 37.
Good. We'll say sine 37 is equal to Y over 9.4. So we find 37, right?
Yeah.
But how do we find Y, by the way?
That's what we're doing.
No, assuming we have this, how do we get Y?
You cross multiply.
I cross multiply. It just becomes Y equal to 9.4 times sine 37, is it not?
Yeah.
So Y cross multiply will give us Y equal to 9.4 times sine 37. So when we get Y, in fact, get it. Let's just finish it up. What's Y? Y will be equal to 9.4 times sine 37. What did you get?
0.60.
It can be 0. 9.4 times sine 37.
9.60.
If you are using your calculator, you can simply press 9.4 times sine 37. In fact, if you just do 9.4 sine 37, you even get the answer. What do you get? 5.6494, right? So 5.649. Because this is not the final answer, so I will leave it to 4 significant figures. Okay, so now we have it. Let's go. How do we now get A? It means we found Y. We found the adjacent for this triangle now.
Then you do cos.
I think that is true. Since we have now found the adjacent, we do cos.
Cos 42.
Exactly. Because for this triangle, this is the adjacent, and this is the hypotenuse we are looking for. So we simply do cos 42 is equal to adjacent Y over A, is it not?
Yeah.
And the Y we found is what?
5.649
over A. So, and so on. Because this is a clue, you will finish up and now get A by cross multiply, isn't it?
Yeah.
So let's move on to this one. How do we get this?
We're looking for.
We're looking for what?
We're looking for this side.
Oh, it's asking us to find. This shows the cross sectional area. Calculate. You see what I was telling you? See what they said? Calculate what?
Angle DBC.
If you didn't know that, how will you know where angle DBC is? This is a past question.
I just said.
No. What I'm saying, assuming you didn't know how to name angles, you won't know where angle DBC is. First of all, where do you think angle DBC will be? DBC. Where do you think the angle will be? It is this angle. See, DBC. So DBC will be this angle. Do you understand? So this is the angle they want. This is the angle they want us to find. So how do we get that?
We can do. We use Pythagoras Theorem.
No, it's an angle. You can't use Pythagoras Theorem when angles are involved. It's trigonometry ratio.
Okay.
But you know this is opposite.
Yeah.
And this is adjacent.
Mm-hmm.
This is opposite and this is adjacent.
Tan X.
So yeah, exactly. So if this is x, we can just do tan x. So tan x, which is DBC, is equal to 1.8 over 2.4. 2.4 squared plus 1.8 squared. We get that. All right, so let me just say a word on this, about this. What are we asked to find? Calculate height DC of the flagpole. DC. From here to here, that's all we need. From here to here. How do we do that?
Angle of elevation.
Yes, the different angles of elevations are given. Do you know that we can treat this entire shape? Treat this entire shape, ADB, the big triangle. What we can do is first of all find this AB using a triangle ABC. ABC. We can find AB. How can we find AB, by the way? We can use tan. Let's call this place X. I mean this length. We call it X. So tan 31 degrees is equal to opposite. What's the opposite? 30 over X. 30 over X. We don't have a potential. Find. So what is X now? Find X. Let me just squeeze it in here so that we have enough space for the rest. I could have solved that thing. So X will be equal to tan 30 over tan 31, right? 30 over tan 31 if you solve it. And what does that give?
50.
30 over tan 31 gives you what?
50.
Just 50.
6 now.
30 over tan 31. You approximated too much. I just wanted you to write.
0.600.
Okay. What I will just ask you to do is just do 30 divided by tan. Where is it? Tan 31. Close the bracket. You get your answer. 49.92. So that you don't over approximate. Because that's not the final answer. 49 point what? 49.92 centimeters or whatever. But that's not what we are asked to find. We're asked to find DC. Now, are you listening to me?
Yeah.
Now that we have found this place, we can find the whole of D to B. We can find the whole of D to B. How do we find D to B using this big triangle? This big triangle. In this
Well, 6B is 30.
in the whole big triangle, first of all, let's find just this big triangle. Don't even bother about this one. Watch it. For that big triangle, tan 37, yes. Tan 37 is equal to opposite, which is this whole place. Sorry. This whole place. So I can call it y. Opposite will be y over x. See, opposite over adjacent. So y over 49.92. So we can find y. So what's y? Y will be equal to 49.92 times. Times, you are cross multiplying, remember? You cross multiply. Cross multiply. So y will be 49.92
37.6.
times what? Tan 37,
That's 37.6.
which is 37.6.
37.
37.6.
Oh,
Give me two decimal places.
Yeah.
Give me two decimal places.
6-1. The top one 6-1.
6-1.
So what's that number?
Excuse me, please. Excuse me. So finally, we need to concentrate so that we can get this done quickly and not waste time further time. Finally, how do we get the DC we're looking for? Watch it. How do we get the D to C we're looking for?
Minus
This exactly subtract, because this whole thing minus 30. So DC will be this whole thing 37.61 minus 30, and that will give us 7.61 centimeters. Alright, that's basically what I wanted you to see. You can look at other other works, you know, in the next page. Some of them are solved, you know. Some you can attempt. Are you seeing it on the next page? Some of them you can attempt. Some are solved. You know, you just go through it. You know, it's basically you start from one, you get something, and then you from there you get the other one, like I did in one of those examples.
Yeah, I understand.
All right.
I know, I understand.
Go to this page. I think this one can serve as further practice questions.